finding the ratio at any angle. In this problem, the point negative 12.5 is on the terminal side of an angle theta. Find all 6 trig ratios, or trig functions of the angle theta at that point. So basically, we're going to find sine, cosine, secant, cosecant, all those at that point. So we're going to first plot the point negative 12.5. So it'll be a negative 12 for x, it's about right here, 5 for y, I'd say it's about right here. So if that's the case, when I create the triangle has to have a hypotenuse that comes back to the origin, and then when you actually form it, the perpendicular side has to come back to the x-axis. So that my reference angle is right here. So that's the triangle. So when I actually have those numbers, for example, this height here is 5. So I know that y value right there is 5. And then this x value in this direction is negative 12. And I actually have to use a negative sign. It's actually important because it's a negative direction. So we want to find all the 6 trig values of theta. I want to first find sine theta at that point, cosine of theta, tan of theta. Sine of theta, as we know, is going to be opposite over hypotenuse. And you don't know hypotenuse, so you really need to take a minute to actually find it using Pythagorean theorem. So you should have set up as 5 squared plus a negative 12 squared equals to r squared, where that's your hypotenuse being r. So you have 169 is equal to r squared, so 13 is equal to r. So you can say plus or minus, but again, the hypotenuse is always positive anyway. So it's 13. So if we want to find the value of sine at this angle, it would be 5 over 13. Cosine would be adjacent over hypotenuse. This is adjacent, so it would be negative 12 over 13. And tangent would be opposite over adjacent, so it would be 5 over negative 12. So the reciprocal identities, cosecant, secant, and cotangent, we already know it's hypotenuse over opposite, or just whatever sine is, flip it. So it's 13 over 5, and whatever cosine is, I'll flip it to find secant, and whatever tangent is, I'll flip it to find cotangent. So you can follow the formula, or just know it's just the reciprocal of the first 6. So here's another example. You try. Actually pause the video right now, plot the point, and find all 6 trig ratios at that point. You should have found the point 8, negative 8 to be in this quadrant. After you actually create the triangle, theta would be here, close to the x-axis. I know this length goes out 8, so it's 8. And this length goes down 8, so it's a negative 8. Again, what you're missing is the hypotenuse. So basically you have to find that. Use r is equal to the square root x squared plus y squared. And if that's the case, it's 8 squared plus a negative 8 squared. So r is the square root of 128. You may simplify that. From previous classes you learned that the square root of 128 can be broken up. So that's really 64 times 2, which means the square root of 64 times square root of 2, which is 8, square root of 2. So either way is fine, but typically, if we can't simplify it, we should. So I know r is going to be 8 square root 2. So if that's the case, we should find sine of theta, cosine theta, tan theta. Take a minute right now. If you didn't make it that far, what is sine of theta, cosine theta, and tan theta? Actually find out what those things are. So you should have found sine to be negative 8 over 8 square root 2, which simplifies. Both of those reduce to be 1s. So it's negative 1 over the square root of 2. And this should be 1 over the square root of 2 because these cancel. And this is just negative 1. Because we have a radical on the bottom, you actually learn you can rationalize that by multiplying top and bottom by the square root of 2. So it's really going to be negative square root of 2 over 2. and this is going to be square root of 2 over 2. So even though it's the answer, this is the most simplified answer. And just so it looks better, it's negative square root of 2 over 2 is what that little thing said on the side. And that's it.